Hello friends, welcome to my YouTube channel RF Design Basics. In this video, I will be writing cut set matrix of this network and then I will calculate the branch current and the nodal voltage at different nodes. So to start with, we have to first draw the equivalent graph. So this is the graph of this circuit, and after that we have to choose some tree. So in this case I have taken twig 4, 5, 6 as tree. So we can draw the cut set by taking the cut where it contains one tree branch, that means one twig, and two links. So we can make cut like this. So this cut we will call as cut 6 because the tree branch involved with this cut is 6, branch number 6. Similarly, this will be C5, cut 5, because here branch 5 is involved, other two are links. So you should have only one tree branch and other should be link. And this is the cut 4, so I will put C4. Now we will take the direction of these cuts based on the tree branch. So here the direction will be in this way because for tree branch 4 direction is in this way. Same way for branch number 5 direction will be in this way, and for branch number 6 direction will be this way. So based on this direction we will be determining whether it will be positive or negative. So let's write the three cuts C4, C5, C6 in left side of the matrix, and then we will assign branch numbers 1, 2, 3, 4, 5 and 6. So there are totally 6 branch in this case, and now I will start writing +1, -1 or 0. So let's take the first cut set C4. Here you can see 3 and 4. 4 is +1 because it is in the same direction, so +1. So 3 will be also +1, 1 will be -1, remaining will become 0. Come to the cut 5. Here we can see 5 is in the direction of this cut, so 1 will be also in the direction of cut. So here you have +1 and 1 will be also +1. Then 2 will be -1. So 2 is -1, remaining branches are 0. It's not connected to this cut. So you can see 3, 4 and 6 is not connected to cut number 5. Now cut number 6, involved branches are 2, 6 and 3. 6 will be positive, 2 will be positive because 6 and 2 are in the same direction of cut. So 2 is +1, 6 is +1 and 3 is -1. Remaining are 0, which is not connected. So from this row we can write the equation for branch currents. First row gives us -J1 plus J3 plus J4 equal to 0. Second row gives us J1 minus J2 plus J5 equal to 0, and third row will give J2 minus J3 plus J6 equal to 0. So these equations we are going to solve for calculating the nodal voltage. Now we will take individual columns to write the branch voltage. So branch voltage in branch number 1 will be equal to V5 So this is V5 minus V4 minus V4. For branch number 2, it is V6 minus V5. For branch number 3, V4 minus V6. V4 minus V6. For branch number 4, it will be just V4. Similarly, branch number 5, it will be just V5, and branch number 6, it will be V6. Now, we are going to apply this one by one. So, let's go back and see the first branch, because in first branch, we have 1 volt source. So, when we write voltage across this 1 volt source will be also added with that. For other branches, like for branch 2 and branch 3, we have only 5 ohm impedance, and for branch 4, 5 and 6, we have 10 ohm impedance. So start writing the first equation. First equation is minus J1. So minus J1 will be minus, branch current will be the branch conductance, that means G, and in this case G will be 1 by resistance. So 1 by 5 into J1. J1 will be V1. V1 is V5 minus V4 and plus 1 volt, because 1 volt is the source there. So that will be added here. Then plus J3 plus J3. J3 is again having 5 ohm resistance, 1 by 5 into J3 is V4 minus V6 into 1 by 5 conductance, plus J4 is just V4 equal to 0. So this is first equation. We can add all the components together. So here we have V4, here also V4 and V4. So by adding all of them, we can get V4 here as 1 by 5, 1 by 5, and this one is 1 by 10, because the impedance is 10 here. So it will be 1 by 10. So you can add 1 by 5, that is 0.2, 0.2 and 0.1. It will become 0.5 V4. Then we have V5 as minus 0.2 V5 and V6 as minus 0.2 V6 equal to 0. Similarly, we can take the second equation, that is J1 minus J2 plus J5. So J1 is again V5 minus V4 plus 1 into 1 by 5. That was J1 we have taken in the first expression. Minus J2, so minus V6 plus V5 into 1 by 5 and 1 by 5 here, and plus J5 means plus V5 by 10 equal to 0. We can write it like this: 1 by 5 V5, 1 by 5 V5, 1 by 10 V5. So here V5 is having 0.5 V5. This left side where we have 1 minus 0.2, so that will become plus 0.2 here. Then V4 is just minus 0.2 V4, and V6 is also minus 0.2 V6 will be equal to 0. This is the second equation. Now we will write the third equation. Second equation I can write below this. It's minus 0.2 V4, then plus 0.5 V5, then minus 0.2 V6 minus 0.2. Then to write third equation, we have to take J2 minus J3, J2 minus J3 plus J6. So J2 is V6 minus V5 into 1 by 5, then minus J3, J3 is 1 by 5 V4 plus 1 by 5 V6 plus J6 is 1 by 10 V6 equal to 0. We can simplify this. There are so many terms for V6, so that will become combinedly 0.5 V6. Right side will be 0 in this case. Then we have V4 and V5. Both are minus 0.2 plus this. So our equation for V4, V5 and V6 here is V4, V5, V6. We can put all these values from there, which is 0.5, then minus 0.2, minus 0.2, and then here minus 0.2, 0.5, minus 0.2, and finally minus 0.2, minus 0.2 and 0.5. Here we have 0.2, minus 0.2 and 0. So we can solve for V4, V5 and V6 using equation option available in calculator, and we will get the value as 2 by 7, V5 is minus 2 by 7 and V6 is 0. So the branch current J1 will be equal to, we have written J1 as V5 minus V4 plus 1 by 5. So V5 minus V4 plus 1 into 1 by 5. That was the branch current for branch number 1. So V5 minus V4 is minus 2 by 7, minus 2 by 7, minus 4 by 7 plus 1 into 1 by 5, which gives us 3 by 35 amps. Then branch current in 2 will be V6 minus V5 divided by 5. So V6 minus V5 divided by 5. V6 is 0 minus 2 by 7 divided by 5. So it is 2 by 35 amps. Then branch current in 3 will be equal to V4 minus V6. So V4 minus V6 divided by 5, where V4 is 2 by 7, V6 is 0 divided by 5. So this is also 2 by 35 amps. Then branch current in 4th will be V4 by 10. So V4 is 2. So 2 by 70, that means 1 by 35 amps. Then branch current in 5, J5 will be equal to V5 upon 10. That means V5 is minus 2 by 7. So minus 2 by 7 divided by 10, which is minus 1 by 35 amps. And J6 is V6 by 10, which is 0 amps. So these answers can be verified using my previous video where I have solved this problem with tie-set matrix. Hope you will be able to solve any problem related to cut set and tie-set matrix. Thank you.